Refrigeration. The term refrigeration may be defined as the process of removing heat from a substance under controlled condition. It also includes the process of reducing and maintaining the temperature of a body below the general temperature of its surrounding temperature. It is an intensive thermodynamic property which determines the degree of hotness or the level of heat intensity of a body. A body is said to be at a high temperature or hot if it shows high level of heat intensity in it. Similarly, a body is said to be at a low temperature or cold if it shows a low level of heat intensity. Used scale or unit. Pressure. Pressure may be defined as the normal force per unit area. The unit of pressure depends upon the unit of force and area. 1 bar equals 14.5038 psi. 1 psi equals 0.070307 kg/centimeter squared. Sensible heat. When a substance is heated and the temperature rises as the heat is added, the increase in heat is called sensible heat. The sensible heat may be defined as the heat which causes a change in temperature. Latent heat. The heat which brings about a change of state with no change in temperature is called latent or hidden heat. Specific heat. The specific heat of a substance may be broadly defined as the amount of heat required to raise the temperature of a unit mass of any substance through 1 degree. Unit kJ/kilogram K. BTU, British Thermal Unit. It is defined as the amount of heat to be added to raise the temperature of 1 pound of water by 1 degree Fahrenheit. Law of perfect gas. 1. Boyle's law. The absolute pressure of a given mass of perfect gas varies inversely as its volume when the temperature remains constant. PV equals K constant. 2. Charles' law. The volume of a given mass of perfect gas varies directly as its absolute temperature when the absolute pressure remains constant. Vt. V/T equals K constant. 3. Giles' law. The change of internal energy of a perfect gas is directly proportional to the change of temperature. Ton of refrigeration. A ton of refrigeration is defined as the amount of refrigeration effect produced by the uniform melting of 1 ton. 1,000 kilograms of ice from 0 degrees Celsius in 24 hours. 1 TR equals 3.517 kilowatt. 1 TR equals 12,000 BTU/hour. 1 TR equals 210 kJ/min. 1 TR equals 400 CFM. 1 TR equals 4.71618 HP. Simple vapor compression refrigeration system. A vapor compression refrigeration system is an improved type of refrigeration system in which a suitable working substance, termed as refrigerant, is used. It condenses and evaporates at temperatures and pressures close to the atmospheric conditions. The refrigerant used does not leave the system, but is circulated throughout the system, alternately condensing and evaporating. In evaporating, the refrigerant absorbs its latent heat from medium air or water or surrounding. While condensing, it gives out its latent heat to the medium, air or water, or surrounding. Mechanics. 1. Compressor. The low pressure and temperature vapor refrigerant from evaporator is drawn into the compressor through the inlet or suction valve, where it is compressed to a high pressure and temperature. This high pressure and temperature vapor refrigerant is discharged into the condenser through the delivery or discharge valve B. 2. Condenser. The condenser consists of coils of pipe in which the high pressure and temperature vapor refrigerant is cooled and condensed. The refrigerant, while passing through the condenser, gives up its latent heat to the surrounding condensing medium, which is normally air or water. 3. Receiver. The condensed liquid refrigerant from the condenser is stored in a vessel known as receiver, from where it is supplied to the evaporator through the expansion valve or refrigerant control valve. 4. Expansion valve. It is also called throttle valve or refrigerant control valve. The function of the expansion valve is to allow the liquid refrigerant under high pressure and temperature to pass at a controlled rate after reducing its pressure and temperature. Some of the liquid refrigerant evaporates as it passes through the expansion valve, but the greater portion is vaporized in the evaporator at the low pressure and temperature. 5. Evaporator. An evaporator consists of coils of pipe in which the liquid vapor refrigerant at low pressure and temperature is evaporated and changed into vapor refrigerant at low pressure and temperature. In evaporating, the liquid vapor refrigerant absorbs its latent heat of vaporization from the medium, which is normally air or water, which is to be cooled. Compressor. A refrigerant compressor, as the name indicates, is a machine used to compress the vapor refrigerant from the evaporator and to raise its pressure so that the corresponding saturated temperature is higher than that of the cooling medium. I also continually circulates the refrigerant through the refrigerating system. It is placed in outdoor unit. Types of compressor. 1. Reciprocating compressor. 2. Centrifugal compressor. 3. Scroll compressor. 4. Screw compressor. 5. Rotary compressor. 1. Reciprocating compressor. The reciprocating compressor is by far the most popular type of compressor you will find. A kind of piston compresses the air by forcing it up and down within the cylinder. As this piston moves down, it makes a vacuum effect that pulls in the refrigerant. As it is forced up, the gas compresses, then moves up to the condenser. Reciprocating air conditioning. Compressor are very efficient. 2. Centrifugal compressor. This type of compressor uses centrifugal force to pull the refrigerant gas, making it spin rapidly with an impeller to compress it down. Centrifugal air conditioning compressors are reserved for extra large and complex vac installation. 3. Scroll compressor. A scroll air conditioning compressor are the newer type on being used. They contain a single fixed coil called the scroll in the middle of the unit, and then there is a separate coil that moves around it. While this is happening, the second scroll then pushes the refrigerant up toward the center and compresses it down. 4. Screw compressor. A screw compressor is extremely efficient and reliable, but it is mainly used in more significant buildings where there is a vast quantity of air that needs continuous cooling. The screw air conditioning compressor unit contains two large helical rotors that move the air from one end to the other. As the refrigerant moves through the compressor, any space gets reduced, which compresses it. 5. Rotary compressor. Rotary compressors are smaller and quieter than other types, so they are popular in areas where noise levels must be reduced. The inside of this type of compressor houses a shaft with numerous blades attached. The bladed shaft spins inside the cylinder, which pushes the refrigerant along the cylinder and compressing it at the same time. Condenser. The condenser is an important device used in the high-pressure side of a refrigeration system. Its function is to remove heat of the hot vapor refrigerant discharged from the compressor. The hot vapor refrigerant consists of the heat absorbed by the evaporator and the heat of compression added by the mechanical energy of the compression motor. The heat from the hot vapor refrigerant in a condenser is removed first by transferring it to the walls of the condenser tubes and then from the tubes to the condensing or cooling medium, air or water. Types of condenser. 1. Air-cooled condenser. 2. Water-cooled condenser. 3. Evaporative condenser. 1. Air-cooled condenser. An air-cooled condenser is one in which the removal of heat is done by air. It consists of steel of copper tubing through which the refrigerant flows. The size of tube usually ranges from 6 mm to 18 mm outside diameter, depending upon the size of condenser. A natural convection air-cooled condenser, ventilation, window. B. Forced convection air-cooled condenser, fan, blower. 2. Water-cooled condenser. A water-cooled condenser is one in which water is used as the condensing medium. They are always preferred where an adequate supply of clear inexpensive water and means of water disposal are available. These condensers are commonly used in commercial and industrial refrigerating unit. A tube-in-tube or double-tube condenser. B. Shell and coil condenser. C. Shell and tube condenser. 3. Evaporative condenser. In an evaporative condenser, both air and water are employed as condensing mediums. Water is pumped from the sump of the evaporative condenser to a spray header and sprayed over the condenser coil. At the same time, a fan draws from the bottom side of the condenser and discharged it out. At the top of the condenser, the spray water coming in contact with the condenser tube surface evaporates. Into the air steam, the amount of heat for vaporizing the water being taken from the refrigerant, thereby condensing the gas. The cold water that drops down into a sump is recirculated to make up for the deficiency caused by the evaporator water. Additional water is supplied to the sump. A float valve in the sump controls the makeup supply, and the eliminator is provided above the spray header to stop particles of water from escaping, along with the discharge air. Cooling tower. Expansion devices. The expansion devices, also known as metering devices or throttling devices, is an important device that divides the high pressure side and low pressure side of a refrigerating system. It is connected between the receiver containing liquid refrigerant at high pressure and the evaporator containing liquid refrigerant at low pressure. Function. 1. It reduces the high-pressure liquid refrigerant to low-pressure liquid refrigerant before being fed to the evaporator. 2. It maintains the desired pressure difference between the high and low pressure sides of the system so that the liquid refrigerant vaporizes at the designed pressure in the evaporator. 3. It controls the flow of refrigerant according to the load on the evaporator. Types of expansion devices. 1. Thermostatic expansion valve. 2. Manual valve or hand-operated valve. 3. Capillary tube. 4. Automatic valve, constant pressure expansion valve. 5. Float valve. 6. Electronic expansion valve. Evaporator. The evaporator is an important device used in the low-pressure side of a refrigeration system. The liquid refrigerant from the expansion valve enters into the evaporator where it boils and changes into vapor. The function of an evaporator is to absorb heat from the surrounding location or medium which is to be cooled by means of refrigerant. The temperature of the boiling refrigerant in the evaporator must always be less than that of surrounding medium so that heat flows to the refrigerant. The evaporator becomes cold and remains cold due to the following two reasons. 1. The temperature of the evaporator coil is low due to the low temperature of the refrigerant inside the coil. 2. The low temperature of the refrigerant remains unchanged because any heat it absorbs is converted to latent heat as boiling proceeds. Types of evaporator. 1. Bare tube coil evaporator. 2. Finned tube evaporator. 3. Plate evaporator. 4. Shell and tube evaporator. 5. Shell and coil evaporator. 6. Tube in tube evaporator. 5. Shell and coil evaporator. 6. Tube in tube evaporator. 7. Flooded type evaporator. 8. Dry expansion evaporator. 9. Natural convection evaporator. 10. Forced convection evaporator. 11. Frosting evaporator. 12. Non-frosting evaporator. 13. Defrosting evaporator. Psychrometry.